be available. So multiplying by 10 will move the decimal to the right. Dividing by 10 moves the decimal to the left. So what's going to happen? You multiply by 10, that decimal moves to the right one space. And so we're going to get 164 and 2/10. And we're going to talk about how we name these things later. So that's what happens when we multiply by 10. Now let's say multiply by 10 twice. Well, that's going to move the decimal to the right twice. We get 1,642. Now, there's another way we can write 10 times 10. We can write it as 100. So we could do something like this. So we can write this differently. We can say that multiplying by 100 will move our decimal point 2 spots to the right, just like multiplying by 10 twice. Now, there's a math trick here, and the trick's going to be this. You might have noticed if you look at the number of zeros, we're multiplying by multiples of 10. 1 0 moved our decimal point over one place. 2 zeros well, that moved our decimal point over 2 spaces. So what we can do, looking at the number of zeros, that will tell us how far we need to move our decimal point. And this is where we're multiplying by 10 multiple times. Let me do a different example. Let's say we're doing this. Well, let's take a look at this. This is 10,000. It's 10 times 10 times 10 times 10. We have multiples of 10. We got 4 zeros. So that means we'll move our decimal 4 spaces to the right. that's going to be our answer. So any questions about that? Watching the chat too. All right, no questions so far. Now, dividing, same thing, except we're going to be moving the decimal to the left. But it's going to follow the math tricks that we just used, counting the number of zeros. We're going to use that for dividing also. If we divide by 10, we have 1/10, so we move the decimal one place to the left. Or you can say we got 1 0 here. Move that one place to the left. And that's going to be our answer. Oh, pardon me. Likewise. Or 10 times 10. Now, in this case, though, I'm going to put this in parentheses. We're going to talk about this later. Or you could say this. We divide by 10. We divide by 10 again. This is going to be the same. I'm going back to this here. I'm kind of skipping around a bit. But this is going to be the same. It's divided by 100. But we can think of it this way. 2 10s means the decimal goes 2 places to the left. Or because we have 2 zeros, decimal will go 2 places to the left. However you write it, like this or like this, you're going to do the same thing. And that's going to be your answer. So the only thing I'm going to mention with dividing and multiplying by tens is this. It's when we have to include extra zeros. What do we do about extra zeros? So let's say we have this. Well, our decimal point is technically there. It's invisible, but it's actually there. We can rewrite this as 53.0 times 10. And you're going to notice something. I've got 110. I'm going to have 1 0. And so I still move my decimal to the right. And now I have 530. Any questions about that so far? Now let's say I multiply by 10 twice. Well, likewise, I have an invisible decimal point. But I'm going to have 2 10s here. So I'm going to put 2 zeros because I've got those 2 10s. And I move my decimal point. And so that's going to be my answer. And the counting zeros technique that we use, that little math trick, works this way too. So in this case, I'm going to count the number of zeros. And that tells me how many invisible zeros that I need to make visible. I move the decimal. And that's going to be my answer. Questions about that? Now dividing, it's going to be the same thing. Let's say I'm dividing by 100. Let's divide by 10 actually twice. Well, this means I move my decimal 2 spots to the left. So I've got my 210. I can move my decimal 1 spot to the left, but then it seems like I run out of numbers. So what I'm going to do is this. I'm going to put in that extra 0, so I have something I can move around. And so 2 10s means 2 moves to the left. And so I'll get 0.0053. Now there's one last thing I'm going to do though. In math, if we have a decimal and there's nothing here, we usually put in a placeholder 0. We'll stick one in like that. But technically, this would be correct. That would be okay. So let's say we have something like this, though. No, I'll do one other thing here. Let's say we have divided by 100. Then I'll show you something else. Again, we can use the counting zeros trick. 0, 0. So that means we need to move left, and then we need to move one more position left. So I'm going to have this. So 2 zeros. So 2 positions left. And so this will get we'll put in our placeholder 0. And that's going to be our answer. So any questions about that? I think that does cover the thing I wanted to show you too. So that's when we work with decimals. That's how dividing by 10 or multiples of 10, like 10 times 10 times 10 works. When we divide by other numbers, it's going to be different. We have to deal with something a little different. We're going to talk about long division later today. But when we're dividing by 10 or multiples of 10, this is a trick we can use. And so just to give you what the multiples of 10 are, or I should say the powers of 10. Well, we can use the multiples of 10. So 10 equals 10. 100 is 10 times 10. 1,000 is 10 times 10 times 10. 10,000 is 10 times 10 times 10 times 10. I'll go one more. We'll do 100,000. So there's a pattern here. I'll give you a second to write this down. But we're going to look for a pattern. And this is sort of a mnemonic or a trick for remembering things. A 10 has 1 0. There's 1 10. 100 has 2 zeros. There's 2 10s. 3 zeros, 3 10s. 4 zeros, 4 10s. 5 zeros, 5 10s. So that's one way of sort of remembering you multiply by 10 many times. So what we're going to do is go on the other side of the decimal. 0.1 will be 1 divided by 10. This is actually 1/10. 100 we divide by 2 10. Thousandth we divide by 3 10s. 10,000 we divide by 4 10s. So each time the decimal we're getting is another 0 between the decimal and the 1. So there's 1 0, there's 2 zeros, there's 3 zeros. Now there's a pattern here. 1 decimal place to the right of the decimal, 1 10. 2 decimal places, divide by 2 10s. 3 decimal places, divide by 3 10s. 4 decimal places, we divide by 4 10s. So any questions about that? So when you're multiplying and dividing by 10, it's moving things around. The decimal will go to the left, or sorry, to the left 1 spot when you divide by 10. If you multiply by 10, you'll move it to the right. All right, so let's talk about naming. How do you name these decimal numbers? So let's say we have this. Now, you might recall from last time that this is called the 1s, this is the 10s, And this is the hundreds. Now, the decimal, to the right of it, we get what's called the tenths. There's a TH in it. So we have the hundreds, the tens, the ones, the tenths, the hundredths, the thousandths, and these will go on and on and on. So those are our decimal places. So how do we name these numbers? Well, what we do is this. We basically break our decimal into two numbers. The number to the left and the number to the right. So we have these two numbers, 243, 174. And so basically what we're going to do is name this number 243, 174. We're going to add a couple extra pieces though. The first extra piece is the decimal. So now when we name this number, we'll say 243 and 174. The and means the decimal point. Then there's the second thing we're going to add. We're going to add in the farthest right place value. So 243 and 174, the farthest right place value, tenths, hundreds, thousandths. That's the farthest right place value. So now when we name this number, 243 and 174 thousandths. So let me do another example. So first off, we have 27. Then we have 23. So 27, 23. But now, don't forget your and. And this right here, tenths, hundredths. That's that place value. So that means the name is 27 and 23 hundredths. So any questions about that? Let me do another example. What about this? Well, that's 3,000. Now, what about the number on the right? Well, 003 by itself is just going to be 3. Now, this is something that comes up in math. You can, if you put zeros to the right of a number, 3, 30, 300, 3,000. When you tack on zeros to the right, it changes things. Things get bigger and bigger. But unless there's a decimal here, just putting numbers to the left doesn't change anything. Now, if there's a decimal here, I put a decimal here or here or here, okay, things can change. But if it's just a number with no decimal points, and you have zeros to the left like this, we'll ignore those zeros. Again, provided there's no decimal point over here. So this here is just 3. So we have our and. And then finally, this place value, tenths, hundredths, thousandths. So what we're going to get is 3,000 and 3 thousandths. Questions about it? So that's how we name decimals. The next thing we're going to look at, we're going to take a look at rounding. And rounding, the key thing to rounding is look to the number on the right. That's the big deal with rounding. So what about this number to the right? And let me show you. Let's say we're going to round to the 10th place. We're going to round to this number. That means we're going to have this number stop at the 10ths. So to do this right, what we're going to do, look to the number on the right. And what are we going to do with this number? Well, if this number is 5 or greater, we bump up this place value by 1. So the place value, what I mean by the place value is the place value we're interested in. So in this case, the place value we're interested in is going to be the 10ths. So we take a look at the number to the right. It's 5 or greater because it's 7. So that means what we're going to do this will increase by 1. And then everything to the right of our place value, the one we're interested in, we just get rid of it. So we'll get 37 and 3/10. Let me do another example. Let's say we have this. Now we're going to round, say, to the 100th. So this is the 10ths, that's the 100ths. So we're going to look to the number on the right. Because this number is 5 or greater, this will bump up by 1. So this will become a 3. And then everything to the right, we're going to get rid of. And that's going to be our answer. Now, what happens if the number to the right is not 5 or greater? Let's say it's less than 5. well then the place value that we're trying to round to, it won't change. It stays the same. Now we still get rid of all the numbers to the right of it, but the place value doesn't increase, it doesn't decrease, it just stays the same. Let me show you. Now let's say we're going to round to the tenths. So the tenths place is right here. Now again, we look to the number on the right. It's a 4. But 4 is less than 5. So that means we're not going to change anything in our tenths place. So it just stays the same. It stays 2. And then all the numbers on the right, we get rid of them as usual. And we'll get 86 and 2 tenths. Questions about that? So adding and subtracting decimals. For this, the key thing, line up the decimal point. So when we add and subtract, the first thing we're going to want to do is line up the decimal points. And then what we're going to do is add as we do regular addition by column. So let's say we have 5.62 plus 7.01. Our decimal points are lined up, so we're good to go. So we just go column by column. 2 plus 1 is 3. 6 plus 0 is 6. And then we want to make sure we drop the decimal down. And then finally, 5 plus 7 is 12. And that's going to be our answer. Questions about that? So let's say we do well, again, we go column by column. 1 plus 2 is 3. 2 plus 9 is 11, and we'll carry the 1 across the decimal if need be. But we do this exactly like we do long addition. Don't forget to drop your decimal now. And then 1 plus 7 plus 8 is 16. And that's going to be your answer. 16 and 13, and this is in the hundreds place, 16 and 13 hundredths. Any questions about that? So let me throw a peculiar one at you. Let's say you're adding these decimals. Again, you're going to line up the decimal points. So we put in the zeros. Now, why did I just put in these zeros? Well, we first line up our decimals, and then if we're missing something, like this is a 2 7/10, and this is 8 43 10,000ths. We had a situation like this, we put in zeros for each of the columns that we're missing in this number. So we'll put in those extra zeros. Now we add column by column. So we get 10 and 7,043, tenths, hundreds, thousands, 10,000s. Okay, so 10 and 7,043 10,000ths. So sometimes we have to add in those extra zeros after we line up the decimals, just because we don't want blank spaces. It's what we're trying to avoid. So that's addition. What about subtraction? Same thing. We're going to line up the decimals. And then we're going to subtract column by column. 7 minus 1 is 6. 9 minus 6 is 3. Put our decimal in. And then 4 minus 3 is 1. And that's going to be our answer. Now, we might have to borrow. And if you haven't done borrowing for a while, it can be a little confusing. So here's the thing with borrowing. 2 minus 8. You can't subtract 8 from 2. So we got to borrow from this. We reduce it by 1. So it goes from 7 to 6. And then that 1, we attach it there to make that 12. And then now we do 12 minus 8 is 4. 6 minus 2 is 4. And then 6 minus 1, that's 5. Again, we just bring down the decimal. So you get a little review on borrowing. Now let's say we have something like this. First off, any questions? We got this situation again. First, line up our decimals. So we have blank spots. Let's fill in those blank spots. Now this is a little tricky. We can't subtract 1 from 0, so we need to borrow. The problem is our neighbor doesn't have anything. Their neighbor doesn't have anything. You have to get all the way down to here before we have something. So we can make this a 6. That'll give us our 1. But these neighbors we skipped over, when you have this with zeros, they become 9s. So when you have to skip past your neighbor 0, and you finally get to a non-zero number that you can borrow from, so this is where the borrowing happens. The zeros you skipped over, they become 9s. And now we subtract. Ooh, can't do 6 minus 9. I gotta borrow again. Make that a 3, put a 1 there. 4 goes to 3, 4 minus 1. The 1 goes right there. There we go. So any questions about that? So borrowing can be a little tricky. So if you're working on some of these problems, and you're like, ooh, I'm a little confused on this one, let me know. Send me a message. I'm more than happy to work with you on it, especially if you haven't done it for a long time. Borrowing's easy to forget. So multiplication. Now, when we added and subtracted, we lined up the decimals. With multiplication, we're going to do something a little different. For multiplication, we're going to line up the rightmost digits. So let's say we have this right here. 3 and 21 hundredths. I'm sorry, 6 and 21 hundredths. 3 and 2/10. Let's say we multiply these together. What we're going to do is not line up the decimals, but we're going to line up the rightmost digits. And then we're going to do long multiplication, but we're going to pretend like the decimals aren't there to start. So we'll do 2 times 1 is 2. 2 times 2 is 4. 2 times 6 is 12. Put in a 0. 3 times 1 is 3. 3 times 2 is 6. 3 times 6 is 18. And I add these up. Now let's take a look at this. We have 1, 2, 3 spots behind the decimal, or 3 digits that are behind the decimal point. So we have 3 digits. For our answer, because we have these 3 digits, we're going to move a decimal over 3 places. So that's the added bit when we multiply with decimals. 1, 2, 3 digits, or 3 spaces that are behind decimal points. That means in the answer, we're going to move 3 spaces to the left. It's always going to be to the left. And that's going to be our answer. Any questions about that? So next we're going to do long division. And just to do a little review with long division, let me do this. Pulling an example from the text here. So we take a look at this. 20 can't go into 5, but it could go into 59. It goes into 59 at most 2 times. Change this to division. So 20 goes into 59 at most 2 times. So 2 times 20 is 40. Subtract, it's 19. Bring down the 7. Now 20 goes into 197 at most 9 times. You can play around with this on a calculator. 9 times 20 is 180. You get 17. Bring down the 4. Now 20 goes into 174 at most 8 times. So 8 times 20 is 160. 14. Now we get into a strange place. Usually what we do in long division is we would call this the remainder. And so our answer would be, well, 20 goes into 5,974. How many times? Well, it goes in 298 times with the remainder of 14. Here's where decimals come in. Remember how I said that 003 is the same as just writing 3? Well, if you do this, 3.00, that's also still 3. 3.0 or 3.00, it's the same as a regular 3. It's just a different way of writing it. So we're going to use that to help us do this division. So instead of settling for a remainder, we're going to do this. We're going to put in a 0.0, and we'll bring this 0 down. Now, when we put in a decimal, when we're dividing, the decimal always moves up. And now we ask the question, well, 20 goes into 140, it actually goes in 7 times. Perfect. 7 times 20 is 140. And now we're done. So the answer, instead of being a remainder of 14, we can also say that this is the answer. 298 and 7/10. The way we do that, we put in a 0.0 that doesn't change our number really. It's the same quantity. And we can bring that 0 down. That lets us continue dividing. Questions about that? All right. So we could have something like this. Now, it goes into 113 at most 2 times. 2 times 35 is 70. And this will subtract that. We'll get 43. Bring down the 8. Now, I'll be honest, doing this one in my head is a little hard, so I'm going to look at what they wrote on the example. Sometimes mental math can be a bit much. Oh, I made a mistake. I'm sorry. Let's see, I made a mistake. Let me back up. So 35 goes into 113 3 times. Not 2, it goes in 3 times. 3 times 35 is 105. There we go. Yeah, if you ever see me make a mistake, let me know, because I'll just keep going down the rabbit hole. So now 35 and 88 goes 2 times at most. 2 times 35 is 70. And then we bring down the 9. So let's see, that's going to be, this is where a calculator is really helpful. I'm going to think, let's see. So 35 goes into 70 twice. That should be at most 5 times. And I'll check my answer so I don't make a mistake. Double check that. Yeah, we're okay. So this will be 175. Subtract. We have 14. Now, once again, we've got this issue where we seem to have ran out of digits. So what we can do is we can add in a 0 like that. This number and this number are the same thing. Oh, pardon me. Sorry about that. Got to watch that cell phone. So let me bring this 0 down. So 35 goes into 144 times. And it is 140. And that's going to be it. We're out of digits. We don't have anything else to divide. So this would be our answer. So any questions about that? I want to emphasize this trick here again. So if you have like 36.7, you can say this is equal to 36.70 or 36.700. In this case, when we're behind the decimal, when we're to the right of the decimal, we can keep adding zeros. That is okay. Like where we get into trouble, we have 3. We put a 0 to the right of 3, we'll get 30. Put 2 zeros to the right of 3. It's changing the number each time. But with the decimal point, these are equal. These are equal. If you have 0.0 and 0.00, it's the same number. We're not changing the quantity. So a little trick there that helps. Any questions about that? There's one more type of division I want to show you. And it's this. So far, I've been playing it kind of safe. Only one number's had a decimal point. What if both of them have decimal points? So what do we do here? Well, what we're going to do is a trick, and it works like this. Start with this number. Let's not make it a decimal. Let's move the decimal as many times as we need to for this to become a non-decimal. So this is what we're going to do first. Then, if we move this decimal one space, we have to move this decimal one space. And this changes the appearance of the problem, but it's actually the same problem. So now we do division as normal. So we have a decimal, better bring it up. And notice I don't bring the decimal up in this stage. After I do my moves, then I bring the decimal. So let me take a look at this. I'm going to follow them. I'm just going to take mistakes and know it. So 38 goes into 113 at most 8 times. And so 8 times 38, 304. We'll get 9. Bring down the 5. 38 goes into 95 at most 2 times. Just for the sake of time, 2 times 38 is 76. So I'll come out to 19. Darn it. We're out of digits, but we've got still more to divide. We put in that extra 0. So 38 into 190, that goes in 5 times. 5 times 38 turns out to be 190. And we're going to get 0. So when you have 2 numbers with decimals, move this one over to the right enough times so it becomes a whole number. And the number of times you move this decimal, that's how many times you're going to move this decimal. So if we had to do something like this, if we're dividing these 2 numbers, I move 2 times. That means this one also moves 2 times. I'll do something like that. If you have something like this, well, this doesn't have a decimal, but we could put one in. And I can see I'm going to move my decimal 2 spots. So I better have 2 zeros. Move this one too means I got to move this one too. And then I go ahead. And in this one, I'm probably going to have to introduce a 0.0 decimal in there, it looks like. So that's decimals. That's what we're going to be talking about with those. So that's 0.4. So we've got about 5 minutes left. So I'm going to start. Let's see. What I might do, because we're starting to fall behind, I want to make sure we're going through this thoroughly so you see these different examples and you're not going to get stumped on the homeworks. So what I'm thinking of doing during the lab is not doing a lab work today. What I'm going to do is record the lecture, and instead of doing lab work, I'm going to actually lecture today. And that does happen in the beginning of the semester, just to make sure we don't fall behind. Usually that first day of introduction kind of puts us behind. So I'm going to actually lecture during the lab today. We'll take a break. We'll lecture for about 5 more minutes, and then we'll take our break, about 15-minute break, and then we'll go into the lab. I'll record that session, and I'll make it available. So if you can't make this lab, it'll be available on video. Also, I'll be doing the same thing for the afternoon lab as well. So we're going to be doing, it's going to be the exact same thing. We left off in the same place for both classes. So if you're taking the class this morning, but you have the afternoon lab, don't worry, you're not going to miss anything. So I'm going to lecture during the lab. We'll go about 5 more minutes, take our break, and we'll lecture. So just to make sure we're not falling behind. So we're getting into percent. That's section 0.5. Now, a percent. Here, I'll get a new pen. This one's getting a little fade. A percent is a special type of fraction. So that's all that it is. It's a fraction that has a special meaning. Now this is denominator, and abbreviated. It means that bottom number. So what a percent is, it's a fraction with a bottom number of 100. So that means if we write 30%, this is just the fraction 30 over 100. If you have 0.15%, you could write this as 0.15 over 100. If you have 200%, you can write this as the fraction is 200 over 100. So any questions about that? All right, so that's what percent means. That's it. So we're going to look at some conversions between percents and, say, decimals and fractions. Now, it may have been a while since I mentioned this, but remember this. A fraction is division. A fraction is the same thing as division. So if we have 3 halves, this is 3 divided by 2. They're the same thing. So when we talk about percents, we're going to do our first conversion. We're going to use this fact. And in the stuff we did with multiples of tens, we're going to use those two things to convert percents to decimals. So we're going to go percent to decimal. So to do that, say we have 33%. Well, this is just 33 over 100. Or, we're going to come up with a shortcut for this, don't worry. 33 divided by 100. Now, what we learned about decimals, or make it 0.0. Two zeros. So we're going to move our decimal 2 spots. And since we're dividing, we're going to move our decimal to the left. Now, I'm skipping a little step here. It's going to come up in 10 dots, but it's 100, because 100 is 10 times 10. You're actually dividing by a 10 and dividing by another 10. So we can think of the decimal moving like that. Let me tie that together real quick. So if we divide by 100, this is the same as dividing by 10 and then dividing by 10 again. It means the same thing. Or if we divide it by 1,000, it's the same as dividing out 3 zeros by 10 and 10 and 10. So that's where I'm coming up with some of these ideas. That's how I know I can move my decimal 2 places to the left. Any questions about that? When we get the PEMDAS, and that comes up in the next section, we'll talk about that. Why is dividing by 100 the same as dividing by 10 and dividing by 10? Why is dividing by 1,000 the same as dividing by 10, dividing by 10, dividing by 10? Well, I'll show you later. Now, there's a shortcut in all this. When we convert percents to decimals, what we're going to do every time is move our decimal point 2 spots left. I'm going to stop right there. So what we're going to do, we're going to take a break. We'll start up again around 10 o'clock, and then we'll continue on. We're going to finish this section on percents and decimals and fractions. And I think we could even do the section fairly quickly, at least introduce PEMDAS, or order of operations. And I'll explain, it gives me a chance to explain why dividing by 100 is the same as dividing by 10 and dividing by 10. There's a mathematical reason for that. But that's going to be it for now. I'm going to stop the recording, and I'll see you in about 13 minutes.